So today we're going to discuss graphing quadratic equations in what is called standard form. Now, the first section of the chapter, we looked at ax squared, and we learned that a makes your parabola open up, open down, and it can also change its width. It can make it more narrow if it's a value greater than 1, or it can make it wider if the absolute value of a is between 0 and 1. Then in the next section, we talked about ax squared plus c. And the plus c, that was your y-intercept. So that caused your graph to translate up or down. In this lesson, we're going to put it all together, and we're going to talk about what happens when you put in these bx into your quadratic equation. Again, this is called standard form. And then in addition to that, we're going to find the minimum and maximum values of a quadratic function. So looking at Desmos real quick, a, as we learned, makes your parabola open up, makes it more narrow, or makes it wider, and can also turn it upside down. Oops, I don't want to do B yet. C moves it up or down. All right, and then when we throw in B, oh, what does B do? Let me put these back to standard. So that's just 1, and make C 0. So what does B do? Ooh, and notice I have that green dashed line in the middle. That's really important. You can see how the graph is exactly the same on either side. Remember, that's our axis of symmetry. So going back to the nodes, in standard form, remember the graph opens up when a is greater than 0. It opens down when a is less than 0. Our y-intercept is c, because that's the value we get when we plug in 0 for. The new part is this. The x coordinate of the vertex is this negative b over 2a, or I like to say the opposite of b over 2a. And a, b, and c come from our quadratic equation. And then the axis of symmetry is the x equals negative b over 2a. The axis of symmetry is actually a line. So if we're looking at our equation in example number 1, a is 2, b is 8, and c is negative 1. So the axis of symmetry, well, actually, let's start with this. Which way does our graph open? A is positive, so our graph will open up. What is the y-intercept? So look at C. C is negative 1, so our y-intercept is the point 0, negative 1. The axis of symmetry is found by doing negative b over 2a, or the opposite of b over 2a. So the opposite of b, that would be negative 8, because b is 8, over 2 times 2, because a is 2. So that simplifies to negative 2. So the axis of symmetry is the line x equals negative 2. Now this is also the x-coordinate of the vertex. Now to find the y-coordinate of the vertex, I must substitute negative 2 back into my function and evaluate it and find out what the y value would be when the x value is negative 2. And make sure you put parentheses around this if you're putting this into your calculator. So the y value of the vertex is negative 9. Oh, there is a spot for the y-intercept. Down there. Moving on to more examples. Now, eventually you're going to be able to figure a part of this out in your head, but I want you to identify a, b, and c every time. So a is the coefficient in front of x squared, b is the coefficient in front of x, and in this case there's no c, so that's an understood 0. okay? So the y-intercept in this one would be 0, 0, or the origin. A is positive, so our graph will open up. Now to find the axis of symmetry, that's x equals, so the opposite of b over 2a. b is negative 2, so the opposite of negative 2 is positive 2 over 2a, and a is 3. 2 over 6, and that simplifies to 1/3. You need to leave it as a fraction. 1/3, and that is the x-coordinate of the vertex. So to find the y-coordinate of the vertex, plug that back in, substitute in 1/3 for x. Now if you're using your calculator and you get a decimal, you can't have the decimal, you can't round it. So you need to make sure you use that math frac button to turn it back into a fraction. So 3 times 1/9, 3 goes into 9 3 times, so that's 1/3 minus 2/3. So my vertex is positive 1/3, negative 1/3. Looking at number 2, first identify a, b, and c. A is the coefficient in front of x squared, which is, in this case, there's nothing there, so it's understood to be 1. B is the coefficient in front of x, and c is the constant. The y-intercept is 0, 5, and again, this is another graph that opens up because a is positive. Now to find the axis of symmetry, I need to do negative b over 2a, or the opposite of b over 2 times a. b is 6, the opposite of 6 is negative 6. 2 times 1, so negative 6 over 2. So the axis of symmetry is the line x equals negative 3, and that's also the x-coordinate of the vertex. Now substitute negative 3 into your original function and evaluate it to figure out what the y value would be at negative 3. So the y value is negative 4. And sometimes you're going to have fractions for a, b, and c. So in number 3, a is negative 1/2, b is positive 7, and c is negative 4. Because a is negative, this particular graph will open down. And the y-intercept is that constant 0, negative 4. To find the axis of symmetry, I need to do the opposite of b over 2a. So in this case, b is 7. The opposite of 7 is negative 7. And then a is negative 1/2. Now I'm going to simplify the denominator first. 2 times negative 1/2 is negative 1, and negative 7 divided by negative 1 is positive 7. So my axis of symmetry is the line x equals 7, and the x-coordinate of my vertex is also 7. Now I'm going to substitute in 7 into my equation, and this is not going to be a nice whole number. So again, if you're using your calculator, in fact, I'm going to go ahead and do this one on my calculator to show you. Let me open it up here. So I've used my calculator and I substituted in 7 where I saw the x. So I have negative 1/2 7 squared plus 7 times 7 minus 4. Oh, what does it say go to? Oops, you know what? I think I used a minus sign instead of the negative sign. There we go. Yep, that should work. And I get the fraction 41/2. Now, if I hadn't used that 1/2 there, I might have gotten a decimal. So remember, if you want to change something from a decimal to a fraction, it's under math, number 1. and that would change whatever in your calculator into a fraction. So this would be 41 halves, and this one would be okay. You could also think of this as 20 and a half, or 20.5. All right, I think I'm going to stop there and move on to video number 2. We'll finish the next example on the next video.